It was a normal day. Sunshine, birds, families boarding a plane, dreaming of holidays. No one thinks about the fuel sloshing in the wings beneath them. We trust the system, the pilots, the engineers. We step onto a metal tube believing it won't become a fireball. But sometimes something goes wrong. A bird strike, a mechanical fault, a simple mistake, suddenly disaster. A jolt, a lurch, and then fire. In an instant, a survivable accident becomes a tragedy. The impact might injure, but it's the fire that kills. Despite all our safety, fire remains the ultimate threat. We've made flying incredibly safe, but jet fuel is still our Achilles heel. The very thing that lifts us into the sky is what dooms us when things go wrong. It's 2025. We have self-driving cars, AI and plans for Mars. Yet we're still flying with fuel that can turn a plane into a bomb. Why, in an age of such progress, are we still strapping ourselves to a potential fireball? It's a question that demands an answer. We've solved so many problems. Why not this one? Why do we accept fire as an inevitable risk? Isn't it time for something better? The world is ready for a safer way to fly, and the answer might be simpler than we think. What if a plane could crash and there'd be no fire? Not a flicker. Imagine fuel spilling everywhere, but nothing ignites. It sounds like science fiction, but it's not. The idea is simple. Separate the danger. Instead of one explosive liquid, use two harmless ones, fuel and oxidizer, stored apart. Alone they're inert. Only together do they burn. No accidental mixing, no accidental fire. Store the ingredients separately, mix them only inside the engine. It's not about inventing magic fuel, it's about clever chemistry. This concept could change everything about travel safety. It's the safety catch we've been missing for a century. Why haven't we done this before? Maybe now is the time. Let's call this idea GeminiFuel, two separate liquids, one powerful result. Component A and component B stored in different tanks, only meeting in the engine. A bird strike or crash, only one harmless liquid leaks, not a firestorm. A gear-up landing, no sparks next to volatile fuel, just a dented plane. GeminiFuel could redefine what a survivable accident means, and it's not just for planes. Think warships, rockets, even cruise liners. Anywhere there's lots of fuel, this system makes things safer. This isn't a minor upgrade, it's a fundamental shift. It's about removing the biggest danger from modern transport. Instead of fighting fire, we design it out of the system. GeminiFuel is that choice. It's the decision to be safer, smarter, and to conquer the skies without tempting fate. Imagine a world where fire isn't the enemy. That's the promise of GeminiFuel. The future of flight could be fire-free. All it takes is a new way of thinking. How do we make this work? Enter hypergolic propellants, two chemicals that ignite instantly when mixed. Rocket scientists have used them for decades, but most are toxic or tricky to handle. The challenge? Find a pair that's powerful, stable, and safe. Maybe modified kerosene and concentrated hydrogen peroxide, or liquid oxygen and methane. Clean but cryogenic and complex, or classic rocket fuels, reliable but dangerously toxic. The holy grail is a green hypergolic pair, non-toxic, stable and powerful. Chemists are searching for it right now. The breakthrough could change everything. Now, how do you get two safe liquids to the engine and mix them perfectly? You need two sets of tanks, pumps, pipes and valves, double the complexity. The injector head must mix both liquids flawlessly every time. If the mix is off, you lose power or create pollution. A computer must control both flows with split-second precision. If one system fails, everything must shut down safely. More sensors, more wiring, more software, everything monitored in real time. It's a monumental engineering challenge, but the reward is a revolution in safety. So why aren't we flying on GeminiFuel yet? Chemistry is the first hurdle. We need the perfect, safe pair of liquids. Next, materials. Many oxidizers are corrosive, demanding new tank and pipe designs. Engines must be redesigned from scratch to handle hypergolic combustion. And then the entire aviation infrastructure, airports, refueling regulations must adapt. The scale of change is massive, but every revolution starts with a challenge. The mountain is high, but the view from the top could save lives. Yes, it's hard, but when did hard ever stop us? We went to the moon. We can make flight safer. This is a call to the chemists. Invent the miracle liquids. To the engineers, build the perfect tanks, injectors and engines. To the dreamers and leaders, have courage and vision. Imagine a world where fire isn't the enemy in the sky, where pilots and families fly without fear of fire. Someone will invent GeminiFuel. When they do, we'll look back at flammable kerosene as a relic of the past. The journey will be tough, but the destination is worth it. A safer sky is possible. We just have to build it.